So, hi everybody. My name is Julie Q, and I'm a software engineer on the Go team at Google. Prior to working at Google, I worked at a fashion e-commerce startup called Spring. And when I was at Spring, I led the catalog team, which was the engineering team that built our entire product catalog. So this meant that I spent a lot of time working with databases and also thinking about the data ingestion process. And the problem I want to talk to you about today is one that I found myself dealing with very often, which is at some point, we all need to edit data in production. And after finding myself in that situation a couple of times, I started to ask myself why. We're all told that directly editing data on our read-write database is bad practice. So why are we all doing it anyways? Well, for me, the first reason is often just because the internal tools that I need are just not available. I would have used a better method, but it doesn't exist. The second is that I ran into an edge case. So sometimes we actually did have the time to build out an interface, but it doesn't do all the things that we want it or need it to do. And lastly, sometimes you just need to make a time-sensitive change. And connecting to a remote database and making an edit can oftentimes just be the fastest and easiest solution. It's really easy to get behind the SQL prompt and execute a query. And usually, if you think about it, there's really not that much of a problem with it, right? So let's say I want to update our products table. And I want to rename the first product in the table to be named Julie's product. So I write this query, and before running it, I'd usually get a coworker to spot check me, look over my shoulder. But let's just say this one time, this needs to happen on a Friday night, hypothetically. And someone on the marketing team comes up to me and is like, Julie, I need you to make this change before the weekend. We promised the brand we would do it all week, and they're going to pull themselves off our platform at this point if you don't do it. So I write this query, I look around, and I realize everyone's already left for the weekend. And at this point, I'm thinking, I could post something in the Slack group and get someone to double check me, but it's Friday, I really don't want to bother anyone. And I'm thinking to myself, this is such a simple query. I have ran queries similar to this a million times before. What is the worst thing that's going to happen? I go ahead and I run this query. I send a Slack to the person on the marketing team saying, hey, it's done. I'm just going to grab some water, head home for the weekend. And then I come back to my laptop, look down, and this is what I actually ran. And for those of you who are not familiar with SQL, the rest of the audience is laughing, probably cringing, because they all know that I just accidentally updated every single product in our database to be named Julie's product. So I'm sure that many of us in the audience actually have disaster stories similar to the one that I just described. And the key here is that these mistakes don't happen because we're all bad engineers. They happen because mistakes happen. And when you're in a situation and you have the ability to make any edit that you want, it sets you up to make this kind of mistake. So today, I want to talk to you about some strategies to make editing safer in your production database. We're going to talk through 5 different strategies today. This includes maintaining a Raw SQL spreadsheet to keep track of our queries, writing scripts and running them locally from your laptop, running scripts on an existing server, using a task runner, and building out a script runner service. And we're going to walk through these strategies in order of the amount of upfront effort it takes for the strategy to be implemented at your organization. We're also going to plot them in order of the benefit you're going to receive. And for each strategy, we're going to talk about 3 things. So how the strategy works and an example of how to implement it, what's great about the strategy, and also what's not so great. And the examples I'm going to use in this talk today are going to involve a Python stack and a SQL database, but these strategies would work for any stack of your choice. So the first thing we're going to discuss is pretty simple. It doesn't actually require any new code to be written or any new infrastructure to be built. It's simply developing a process to make sure that we get spot checked when we make edits to production. So what does this process look like? Well, let's go back to the query that I had intended to run for the marketing team. So I'm trying to update the first product with ID 1 to be named Julie's product. And what I did a few slides ago was I just did that, and there was no supervision at all. So what we started doing is we started maintaining a Google spreadsheet to record manual SQL queries that were actually being run against production. This Google spreadsheet let us collaborate and review each other's queries before they were executed, and it also gave us a checklist for what needed to be done before running anything against production. So here's what that looked like. So the first step would be for me to add a record to the spreadsheet. Some information I'd fill out would be my name, the date, a description of what I'm trying to do, the query itself, as well as a reviewer. And then the reviewer would look at the query and either approve it or request changes. So after a couple back and forths, the next step is for the reviewer to go ahead and approve the query. And once you get those 2 thumbs up, the last step is to go ahead and run the query. So in this step, we ask everyone to do their manual edits inside a transaction. So that way, if you notice that you made a mistake halfway through, it's really easy to actually roll back. So what's great about this system? Well, the first is just that it's really easy to implement. You could get this process started during the lunch break today. All it really takes is making a spreadsheet and sending an email to your team about what to do. But the effects are really powerful. And this is because this strategy provides you with an audit trail. So after we implemented this process, we went from having a ton of ad hoc queries that we hoped people were getting checked to actually having a log of everything that was being run against production and who had looked at it. And this audit trail not only gave us information about who was running the queries, but also why they were actually going about doing things this way. And it led to several discussions where we might think about investing in internal tools or really just rehauling a system and rebuilding it all together. And lastly, what's great about this system is it promotes the right behaviors. So it helps to not only encourage everyone to be more careful, but it also teaches people what the right things are to do. And if we think about the journey that will go on in this talk, right now we have a strategy that gives us the benefit of data editing and requires very little upfront investment. We've also implemented a manual version of a code review process and an audit trail. And this is great because at your average startup, raw SQL edits are probably not going to go away. But this process makes it so that now we're empowering engineers to avoid mistakes and make sure that they're getting spot checked. Introducing this process also makes it just slightly more painful for people to run queries, so it encourages them to build better tools. So what are some things that are not so great about this process? Well, the first is that it's still kind of easy to make mistakes. After all, we're just assuming that people are going to copy and paste queries from the spreadsheet into the SQL prompt, but that might not be true, and even then, that can lead to errors. And the audit trail is also being maintained manually, so that opens up another room for error. After all, there's nothing really preventing someone from running an unchecked query. And lastly, while it's relatively easy to update the name of one product, it can be kind of difficult to execute long and complex logic with raw SQL. So if your query takes a really long time to run, it's going to time out. For example, let's go back to that query that we have been trying to run, and let's just say that we want to run some variation of it that's a little bit more complex. What if the marketing team didn't want me to update a specific product ID? What if instead they said, hey, there's a bunch of products for this brand, Julie's store, that don't have a name. And if they're active, can you please change their name to Julie's product? So we can see how these queries can become a bit more complex, and we want a system to be able to handle running them other than just raw SQL. So let's talk about our next strategy, which is going to help us run these long and complex queries. So the next strategy is we're going to write scripts and run them locally on our machines. And here's what that process looks like. To run scripts locally, we'll start by writing the script. You'd convert that SQL logic to code in your programming language of choice. And then we're going to form a connection to the production database. So you can do this using either a VPN or an SSH gateway. And lastly, we just run the script from your terminal. In Python, this is what that command might look like. And I often like to write my scripts in such a way that I would add a dry run flag. So that way I can preview the results before actually committing anything to production. So what's great about this new strategy? Well, the first is that scripts, unlike Raw SQL, are reusable. So you can just write the script once, and then the arguments can be passed in. And if you need to manipulate the outputs of the script, it's easy to simply just pipe it into a text file or another script that you might want to run. And lastly, writing a script gives you access to all of the code in your repository. So it becomes easy to import functions from common code or reuse logic that already exists. And now looking at our journey, we have a strategy that gives us two benefits. We can edit data, and we can execute things with somewhat complex logic. At this point, we haven't had to set up any infrastructure, so the upfront investment is still really low, although it may be a bit higher than just running queries with Raw SQL. But what aren't we getting with this process? Well, the first is that code review isn't being strictly enforced. So someone can still write a script without any form of code review. And the outputs of the script are only available on the user's machine, so they're going to go away as soon as you exit out of the terminal. And lastly, we can run into network connectivity issues. The script's going to stop running, say, if the internet dies out, or the user accidentally closes their computer. Which kind of begs the question, what are we supposed to do if our scripts take a really long time to run? For example, what if I wanted to run this query many times? In fact, oftentimes, I had to run this on all of the products in the database, which could be up to 50 million products. And when I first started working at Spring, I often would find myself just coming into work really, really early on those days. And I would turn on my laptop and just start running the scripts. And this was until one day, I was just sitting there waiting all day, and by the end of the day, only about 25% of the products table had actually been processed. So I talked to my manager at the time about workaround strategies, and we kind of sat there thinking, wouldn't it be nice if we had a computer that was already set up with all this information, but unlike my laptop, it was just on all the time? And well, conveniently, pretty much every computer, every single company has computers set up just to do that. After all, that's how we keep our websites up and running all the time. And so the next strategy we're going to discuss is how to run scripts on an existing server. And here's how that'll work. So similar to running scripts locally, I'm going to start by writing my migration script. Because we're now running the script on a remote server, the second step is to get the script actually onto the server. There's a lot of different ways you can do this. You could deploy or fetch a copy of the repository that the script is in. You could upload or transfer the script. What we used to do is we would compile code before deploying an application. So I would actually just manually copy the script onto the remote server. And I often use Jenkins as the server to run my scripts on because it's where we would run automated tasks like our deployments. So after the script exists on the server, the last step is just to SSH in and run the script inside a session. And in general, this method of running scripts on Jenkins worked really, really well for me, and it got me through to shipping some major projects. This was until one day. This message happened to pop up in our engineering Slack channel. So our on-call engineer, Maya, happened to notice that she couldn't SSH into Jenkins, and she pinged her DevOps lead, Justin, to check if it was down. So I'm a really responsible engineer, so of course I'm also going to hop on, and I'm going to check also. And I also confirm, yes, Justin, it's down. So then I went back to doing my work, writing some code, until 2 minutes later, I had a realization. I think I shut down Jenkins. And my hunch was right. It turns out that Jenkins was down because the script that I was running on it was using up all of its CPU, and as a result, none of the other engineers could deploy their code. It was a pretty easy fix. All Maya had to do was reboot the instance to bring Jenkins back up, which means that running code on an existing server is still a great strategy for running long scripts, especially if you monitor it a little bit more closely than I did. But it was a lesson for me that we should really look into place to put better infrastructure into place. But before we talk about what are the improvements that can be made, let's talk about what's great about running scripts on an existing server. So the main thing is that now you can run long scripts, or really any scripts, without needing to leave your computer on. You can just start up your script in a session and then come back and check it later. And similarly, because we're running the script on a remote server, we have the benefit of a much more reliable network connection. So we don't have to worry about things like the Wi-Fi died out or my laptop battery died. And lastly, you're now getting all of the benefits of running scripts on a server, but we didn't need to build any new infrastructure. So when we look at this strategy in comparison to the other two we've discussed about, the main benefit here is now we have a way to run long scripts without worrying about our laptop shutting off. The strategy has relatively low investment costs. There's definitely some DevOps configuration work involved, but it's still a relatively easy system to rely on. So what isn't this strategy getting us? Well, the first is that the scripts that you run, like you saw in my case, they can affect the resources on your server. So in the example I used, we used up too much CPU, but your script might also end up consuming too much memory. And second, you need to copy the script onto a remote server. You need to SSH into that server and then start a session just to run a script, which isn't necessarily the most user-friendly experience, and it opens up a lot of room for error. And lastly, we still don't really have a good persistent audit trail. So there's a lot of logs available on the server, but probably only the person that ran the script can actually see them. So we can do better. So the next strategy we're going to talk about is one that's more user-friendly for engineers and actually gives us a persistent audit trail. So the next strategy we're going to talk about is using a task runner. A task runner is something that lets us automate the task involved in running a project and running a script, and it includes doing things like SSHing into the server for you, setting up the virtual environment, getting a copy of the code, all of those repetitive things that we had to do before. So we had set up a task runner on Jenkins because we used it as our continuous integration server for builds and deployments. Jenkins also lets you write code and register some arbitrary jobs, and the Jenkins build page gave us a good user interface. So similar to the last strategy, we'd write the script, we're going to get it code reviewed, tested, and merged. And then lastly, instead of SSHing into the server to run the script, we'll instead just run it using the Jenkins interface. This is what that UI would look like. You would type in the file path, all of the arguments you needed for it, and then click Build. Jenkins will then take care of setting up a virtual environment, connecting to the remote database, and then running the script with all the arguments you inputted, and you can just watch it happen. And this strategy is great because it's the first one that's actually gotten us detailed audit logs. The logs make it really easy to monitor the progress of the script, and it's useful to be able to see what actually is happening. And because the first step of our task runner is to get the latest version of master from the repository, all of the code that's being run has to be code reviewed and merged. And it means that we can now enforce code review and also provide a way to write automated tests before scripts are run. And lastly, we can now run our scripts from a user interface as opposed to needing to SSH into a server, which minimizes room for error. So at this point, we've actually come pretty far on our journey. We have a lot more new features available to us, including code review, automated testing, an automatically created audit trail, and a user interface. But setting up a task runner can take a bit of time. But when I think about the amount of time that it saved our team of engineers because we didn't have to do cumbersome things like manually copy code onto a server or figure out what mistakes were happening when we have no logs to look at, there's a lot of reasons that the upfront cost is really worth it. But there's still some reasons that it's not exactly what we want. And one of the main reasons is that every single time you want to run a script, you still have to manage the credentials that are needed for the script. And this is going to be particularly annoying if you have a ton of credentials. This was actually the main driver for us to look into new solutions, because even after the task runner had launched, I found out that one of our engineers was still running long scripts by copying them onto Jenkins, simply because his script had over 30 credentials, and it was easier just to store a text file onto the server and pipe them into the script whenever he needed to run it. There's also not a clear separation of environment here. So because we're just passing in arguments, it's possible that we could pass in the database string for our dev environment and accidentally use some credentials from production. That's not great. And lastly, there's still no system in place for us here to verify the arguments being passed into the script. So for example, if I had a script to update the name of product 1, how do I know that I did product 1 instead of 2, or that even I spelled Julie correctly? So all of those really annoying problems really got me thinking. We have all these problems that we're dealing with. Configuration management, logging, separating environments. Haven't we solved all of these problems before? After all, if we think about any of our existing applications, they all do this. So why have we been trying to reinvent the wheel here instead of just building something with the tools that we already know and are familiar with? So that's what I did next. So I decided to use our existing tools to build an application to run our scripts on, our own internal script runner service. And it would be architected like the other applications that we had. So here's what that looked like. So an application server was set up in every single environment to run scripts. Each server had access to its own set of credentials for that environment, which was common to all the other instances there. And then the application was set up to connect to the database in its respective environment. So the steps for running the script are really similar to the steps with using a task runner. You would write the script, you would get a code review, tested and merged. And then lastly, the key difference here is that the task runner, for the task runner, we had to input a series of command line arguments, but now all we have to do is select the environment we need to run it in. And this is what this UI looks like. So we would go to the interface, type in the file path of the script, pick the environment, and then just click build. And all of the command line arguments that we had to manually enter before, they're now available as environment variables on the script runner server. Which brings us to some of the key benefits of this service. So the first is that we now have a form of centralized configuration management. The second is that the strategy allows us to maintain a clear separation of environment. But lastly, this system is also the most user-friendly of all the ones that we've seen. And the amazing thing is that with a script runner service, it doesn't have to stop there. There's even more stuff you can build out. So say we have a lot of people that need to run scripts at the same time. We can just parallelize and scale our instances to make that possible. If we want to preview the effects of what's going to happen, we could build in that sort of functionality. And in the end, it's really up to you to customize your own version of script runner. So we've seen today a spectrum of tools that you can use for editing production data. And some of you might now be wondering, which strategy should I use? Ultimately, that really just depends on the needs of your team and your willingness to invest in the upfront cost of building the tool. So if your team is small and speed is really important, then making a mistake once in a while might not be the worst thing, and running Raw SQL or local scripts might actually be the best strategy. But as your teams grow, with larger teams, benefits like logging and auditing become really important. Because you can't just have 50 engineers jumping into a Google spreadsheet every time you need to run a SQL query. And you might also need a more centralized way to manage all of your credentials. So in that case, building a script runner service might make more sense for you. The key is that as you think about hiring and growing the size of your engineering organization, make sure that you're also upgrading your infrastructure and internal tools to support the engineers in their work. Which brings me to a key learning that I had in the process of developing tools for running scripts, which is that when you're building tools for your team, it's really important to not just think about safety, but also think about speed and usability. After all, that's why we're all getting behind the SQL prompt in the first place. And in the same way that it's important to think about the end user when building our consumer application, it's also really important to make something usable for your engineers. And on the flip side, a lot of times we all find ourselves doing things that we know we shouldn't be doing. We're all guilty of looking at something thinking, this is not ideal, we really shouldn't be doing this, and then 2 seconds later find ourselves doing it anyways. So you should invest the effort to stop doing that early on, ideally before you change the names of 50 million products to Julie's product. And thank you all for listening. I'll be here for the rest of the conference, and you can also find me on Twitter.